Elixir is a programming language built on top of the Erlang virtual machine. Elixir allows metaprogramming, polymorphism, and a web framework called Phoenix that has drawn positive comparisons to Ruby on Rails. Jose Valim is today's guest. He built Elixir to augment a language that he loved, Erlang. On a Software Engineering Daily, we interviewed Joe Armstrong, the creator of Erlang, and that was a very popular show. So I encourage any listeners who are fans of Erlang or who are completely new to Erlang to check out that episode. Erlang was built with concurrency in mind, and it has been rising in popularity as more of our applications are written to be distributed. In today's episode, we will discuss what Jose is building on top of Erlang with the Elixir programming language. Before we get to that episode, a few things. Software Weekly is a newsletter that we put out every Sunday evening to condense what happened in the world of software over the previous week. You can sign up for Software Weekly or join our Slack community at softwareengineeringdaily.com. If you like this show, you probably will like our Slack community. You probably will like our newsletter. Also, Software Engineering Daily is looking for sponsors. If you are interested in advertising on the show, if you want to reach several thousand developers, send me a message at softwareengineeringdaily@gmail.com. After a quick message from our sponsor, we will get to this episode, Elixir and Erlang with Jose Valim. The nature of money is changing, and software engineers are the creators of that change. On Software Engineering Daily, we've done shows about Bitcoin, automated trading, Ripple, and other financial technologies. One thing is clear, there has never been a more innovative time in financial technology. Untapped has jobs at the world's leading fintech companies. Untapped is a platform for matching software engineers with jobs at fintech companies. Sign up at untapt.com/sedaily and find a job in fintech. If you're invited to interview, Untapped will send you a collection of 5 books relevant to both your interview and this week's episodes on Software Engineering Daily. These are books like Cracking the Coding Interview, or Manning books, or O'Reilly books, and they're really going to help you get the knowledge that you need to get the job that you want or create the piece of technology that you want to see brought into the world. There's more at untapt.com/sedaily. That's untapped.com/sedaily. Untap your talent today at untapped.com/sedaily. Now let's get back to this episode of Software Engineering Daily. Elixir is a programming language built on top of the Erlang virtual machine. Jose Valim is the creator of Elixir. Jose, welcome to Software Engineering Daily.
Thank you.
In order to explain what Elixir is, let's first discuss Erlang a bit. What are the strengths of Erlang?
I'm going to take my time to answer that question. So Erlang, to me, one of the strengths is that it's really unique in terms of what it was designed for. So it was designed by Ericsson, which is that communication company. And when they designed it, they had a very specific set of requirements and use case in mind. If you are building telephone switches, you need to be able to handle a bunch of phones connected and information coming and going at the same time. You need to have switches communicating with each other. So they had all those requirements, and they decided to build this language, this runtime, this virtual machine. And I think that's where its strength is. So I like to say, for example, if you want to use Elixir, it's going to really shine on everything that runs on top of on top of TCP or UDP, right? And that's really anything. Like if you need to write your own protocols, or if you want to build a regular web application, or even if you're building distributed systems, which we see a lot, for example, with databases like RAC running on it, right? So the strength is exactly so going more straight to the answer, it's in building concurrent systems, it's in building distributed systems, things that are running on top of the network. And it's all thanks to this very unique design and requirements that they come up with, which later we found out that all those design decisions they made, they are also really good for the web. And that's why we saw, I would say, in the last 10 years, like a very growing interest in Erlang.
Absolutely. And if listeners are still wondering why we are discussing Erlang, I'd love to put it in an even broader context. Erlang is rising in popularity, and Elixir is rising in popularity with it because these languages have great functional and concurrent features. And for listeners who are unfamiliar with concurrency, they're unfamiliar with distributed systems, why is the programming world becoming more interested in concurrency, in distributed systems, and in functional languages? Why are distributed systems rising in popularity, and why are functional languages a good way to attack this problem?
That's a great question. So we have a saying in the programming community. We have been saying this since 2005, which is the free lunch is over. Because in the past, what we had, for example, my first computer was like Pentium 100 megahertz. And then in 2 years, you could buy like a Pentium 400 megahertz, right? Like you would wait 2 years and everything would get much faster. So, and what happened for us as developers, right, is that we would write some code. And by waiting 2 years, that code would get like twice faster. We didn't have to work on it. We just had to wait, right? And that was really, so that was our free lunch, right? We had things getting faster all the time without doing any work. So when we say the free lunch is over, is exactly because our computers are not getting faster in this way anymore, right? That's why we are not buying computers with 8 gigahertz. What we're starting to see is that our computers, they have more and more cores, and that requires a change in the way we write software, because if we want to have our software now running faster as time passes, our software needs to run on all of those cores. So that's really the main reason, right? Like the hardware changed, and now we need to change the way we have to write software, and that's causing the changes on everything else that you asked as well. So, for example, why the interest? So that explains the interest in concurrency, right? So we need to use all the cores. But what is the interest in functional programming? So functional programming values a couple other different aspects that we are used with from the perspective of imperative languages or object-oriented languages, which is, for example, immutability. We don't want to keep changing things. So to try to give a more precise example, what this means is if you are using a imperative language, what you have is that you have something stored in your memory, right? It can be a number, it can be a name, it can be anything, right? And then when you want to change that, you just go and change whatever is in memory, whatever that thing was referencing, and you just go and change it. The problem that we have now that we're talking about concurrency is that now what can happen is that because we have more than one core, we have more than one thing working at the same time. So what can happen is that you can have 2 cores trying to change that same place, and you're going to run into issues, right? Because, who is going to win? Who is going to write first? Who's going to write second? What happens if they're both writing at the same time? So functional programming came a long, long time ago, right? It has been there for a while. But right now, a lot of people, they're really seeing, the benefits in writing software in a way that we are not changing things in place. We are thinking about transformation, how we transform those things. And the interesting thing is that it actually leads to better software, in my opinion, because as so Rich Hickey from Clojure, he explains it really, really well. When you mutate things and change them in place, you add the concept of time, right? Because when you're looking at that thing in memory, as time passes, it changes. So we are introducing this idea of time into our software, which makes it harder to understand. But with functional programming, because we have immutability, which is, we found out that helps us write concurrent software, it also helps us to write more maintainable software because we are removing this time aspect from our code and everything is easier to grasp and easier to understand. So, a lot of people like to go into discussions like, what is functional programming? What is object-oriented programming? And there is not really agreement. But to me, functional programming, what it is about, it's about making the complex parts of your system explicit, right? So mutation, exactly because I said, it's adding time to your code. That's actually a source of complexity because everything gets harder to understand. So we want to make it explicit. We don't want to make it the default. We wanted to make it really obvious, really in your face that it is there. So that explains why functional programming right after concurrency. But you also said about distribution, right? So what is the, we like to talk a lot about distributed programming as Erlang and Elixir developers. And the distributed aspect is really what made me fall in love with Erlang and what led me to the decision to write Elixir, the Elixir programming language, which is, you see a lot of people, exactly because of this story I told about all cores, you see a lot of people worried about concurrency, like, oh, now is the age of concurrency, we need to solve that. But the interesting thing about the Erlang virtual machine and those requirements I said at the beginning is that when Erlang was designed, you're not worried about concurrency. It was in the 80s. You didn't have multiple cores, right? What they were worried about was distribution. And then when concurrency came and started to become this thing everyone is talking about, they realized that concurrency is actually a special case of distribution, because distribution, you have a lot of things happening in different machines, and concurrency is kind of the lucky case where you have a lot of things happening in the same machine. Right? So they said, oh, this model that we have here that is great for distributed programming, we can just bring it and make it work for concurrency too. And that is just fantastic because, so when I look at it, to me, I see like, a lot of people, they're worried about concurrency and they're adding concurrency related features to their languages and so on. But to me, Erlang, it's like they are ahead of the curve. They already solved the long term. They're already talking about concurrency. So, if you have things running your machine and then you have a machine with more cores, you want to have better concurrency. But at some point, you're going to reach the machine resources, right? And you cannot buy a machine with 10,000 cores. What you need is that you need to use more machines. And those abstractions, which is the abstractions for distribution, they are already there, already for us to leverage. So, that's really, to me, that's really the reasoning why I find the whole virtual machine runtime so beautiful, because it was really, back in the 80s, it was really ahead of its time. And today, it's still ahead of its time. And we see like really nice applications of when writing software, when writing frameworks with Elixir, we see those benefits showing up.
And then so in 2010 or 2011, when you started working on Elixir, when the first commit to Elixir was made, eventually you had three goals in mind: extensibility, productivity, and compatibility. I'm not sure if you had these goals in mind when you made that first commit, but over time, Elixir has evolved to have these goals in mind: extensibility, productivity, and compatibility. And I'm guessing that these are the diffs between Elixir and Erlang. You wanted to add extensibility, productivity, and compatibility to Erlang. Is that correct?
Yes. Yes. So you're right. They are not there since the beginning. So I tell this story that when I started working with Elixir is because I was already working with Erlang for some time, and there were a couple things that I felt like I was missing. So I had a need, like I had a problem, and I didn't know the answer yet. And actually, my first attempt to solve those problems, they were actually really, really, really bad. So after a while, where I was thinking about those problems, researching other programming languages, I came up with the reason. I came up with better solutions for those problems, and those goals that you said helped me, establish and control those solutions and see, it helped guide the design process, right? So, for example, one of the things that was really bad in the first versions of Elixir was that I was trying to kind of push the virtual machine to its limits, in a sense, like it was very exploratory, like what I can do. So some of my decisions, they did not integrate really well with Erlang, with the virtual machine. So and then I realized, what is the point? Like, if I am writing this language because I want to leverage this virtual machine and this runtime as well as much as possible and as well as possible, it doesn't make sense for me to have a solution that it's not going to use it 100%. That is like pushing it to a weird limit and make things a little bit uncomfortable. So that came the goal of compatibility. I want to be compatible with everything that the virtual machine and the runtime has to offer. So this kind of said, like, this is the starting point, right? So as a language, this is my starting point. I need to be compatible with what is there. And then the other two goals, they are building on top of that. So the first goal is productivity. The other goal is productivity, one of the other goals. And the thing about productivity is that it's hard, right? Like to measure. How do you say that one language is more productive than the other? So the way we focus about productivity in Elixir, it's about having very good tooling, having a very good developer experience. For example, I like to say, if you, as a developer, if you're using Elixir or if you're using Elixir library and there's an error message and you don't know how, you read the error message and you're like, okay, I read the error, but I have no idea how to move on, that's a bug, right? Because the error needs to tell you, this happened, those are causes that you can look at it, and here is what you can try to do to fix that.
So the compilation and the debugging process, that can be a benchmark for productivity.
Yes, definitely, right? You should not be fighting the compiler. The compiler should be helping you as well as the runtime. And this is so. Of course, there are still many situations where, because you are integrated with the existing environment and runtime, where we unfortunately cannot give those excellent error reports. But whenever we can, it's an active area of improvement. And whenever we can, we are, improving those error messages and trying to make it clear what went wrong and how you can move on, so you don't get stuck on those things. For example, also, what we have in the language is that we pay a lot of attention in the getting started experience. So, and a lot of attention on documentation, providing good documentation with a lot of examples and making everything accessible. And the reason of all of this, so first of all, we obviously want developers to feel productive, right? But the reason that brought me to this goal in particular is that if I want folks to learn more about Elixir or fall in love with Erlang like I did and start writing software, they need to learn a lot, right? Because we're talking about a functional programming language. So if you're coming from an object-oriented language, you need to design your software a little bit differently, right? You need to learn about immutability and how that's going to affect your code. We are talking about concurrency, and a concurrency in Elixir is something similar to the actor system. We have this idea of processes, which are very cheap, very lightweight thread of computations. You can create literally millions of them in your machine, but you need to learn about them and learn how to reason about them. So there are a lot of things that you need to learn, right? And so the documentation needs to be accessible. And given that you need to learn all of those things, we don't want you to get stuck in a compiler error, or for you to get stuck trying to create a new project because you don't know how to choose a build tool, how to listen to fetch our dependencies. So we want to take those things out of the way so you can focus on the things that you really need to learn to be productive in Elixir and move on.
And so when we're talking about trying to determine what the high level value is of Elixir, I think that there's this great example that I actually read just this morning. It was trending on Hacker News. Joe Armstrong, the creator of Erlang, published a blog post called Managing 2 Million Web Servers. And in this post, he was comparing how the Apache web server handles connections versus an Elixir or an Erlang web server. And just now you were talking about, like, how do you understand what is the value that Elixir or Erlang is actually delivering to you? And I think Joe Armstrong really encapsulated in this post. And the key point he makes is that an Apache web server is a single server that gives each user a connection, but Erlang actually creates a small server for each connection. So if a bug occurs and the server crashes, it doesn't cause the entire system to fail in Erlang. Only that one process crashes and the other connections stay up. So explain why this is so important. Explain why this is core to the value of Erlang and how this contrasts with a centralized web server like Apache.
Okay, that's great. So there are a couple of things we need to understand here. And so one, we already talked about it. And one of the reasons why it's important is exactly from the point of view of concurrency. So if we can create a bunch of those, as I said, processes, which are not operating system processes, but those very cheap, lightweight thread of executions, if we can create a bunch of them and they're all running at the same time, we know how to leverage concurrency, right? And that's one of the important aspects. But the other aspect here, which is the one you brought, like, if something goes wrong in one of those tiny processes, it's going to happen just there. It's not going to bring the whole server down. That's absolutely true. And I want to clarify that for someone can be, so someone's going to listen to this conversation, they'll think, wait, but in my Apache, if something goes wrong with my connection, my whole server is not coming down, right? But what is happening there is that they need to use language constructs like try catch or rescue. It's a very common saying, like, to catch an exception, to rescue an error. And the trouble with that is that, in my opinion, it is a really, really bad habit, because an error, an exception, is a way of our software to say, look, something went wrong. And when we are catching those, when we are rescuing those, it's like we're saying, hey, okay, thank you, just continue doing whatever you're doing. I like to say, like, it's kind of say, look, oh, I think I broke a leg, and then you say, okay, continue running, right? That's kind of like what we are doing to our code. We are ignoring those things that are important, and because that's the only way we can do error handling in a lot of languages, we are putting those all around as kind of saying, okay, I just want to make sure that whatever is happening in this code block, if something goes wrong, that it doesn't leak, so it doesn't blow everything up. And sometimes it still happens, because sometimes a framework or a library, executes some code and does not put those safe blocks. And then when something goes wrong, it brings everything down, right? Everything crashes. And you can look for bug reports for this in a lot of different languages. Like, you can search for JBoss in Java, bringing the whole server down when they are executing some callback because they forgot some safeguard. You can find examples in Ruby, Python, right? So the reason why this is different with Erlang and Elixir, it's because, so I have when I do a presentation about Elixir, there is a slide where I show, like, a circle, and I say, like, this is your code. Like, this circle here, this is your code in imperative and object-oriented languages. All your code is in there. And it's a chunk of sequential code. And that's why concurrent programming is so hard on those languages, because you have, like, sequential code, and then you have threads that is executing this code in all those different ways, right? You need to do the interleaving on the code that you're looking at your screen. It's hard to understand. And the thing about Elixir and Erlang is that you still have the sequential code, but the sequential code exists, they all exist in those different processes. It's like, you can think like every one of these processes, like, is a different program, and they're interacting with each other. And then when you need to reason about the sequential code, you need to reason only about the context of that thing. And when something goes wrong, right, in one of those processes, it's not going to affect the other one. They are all isolated. And this isolation is important because it goes back to concurrency. That's why they can all run at the same time, right? If you have a bunch of things that they do not really interact with each other, they do not really depend on each other, you can make them all run at the same time, and that's how you get concurrency. And when it comes to error handling, right, what we do is that if something goes wrong in a process, we say in those lightweight thread of executions, what we say is if something goes wrong, just let that process die, let it crash, right? And the reason for that is because we have things that we call supervisors, and those supervisors, they are going to see that something that had a particular responsibility died, and it's going to create a new one on its place, right? And this is the second factor. So I said, the reason why processes matter, coming from the Joe Armstrong blog post saying about a bunch of web servers and a bunch of processes. So the first one was concurrency, and the second one is error handling, and that's the contrast between error handling in Elixir and Erlang and those other languages. So when we are doing try catch, begin rescue, catching exceptions, catching errors, and here we are saying, if something is wrong, we are going to let it crash. And the reason for that is because we have the supervisor, and the supervisor is going to start a new thing to continue doing its job. So for example, imagine that you have a queue and you need to take data from the queue to process it. Okay? Now imagine there's a bug in that code. In something like in a language like Java, what I would do is that, there's a bug in my code, so what I want to do is that I don't want to stop taking things from the queue, is that I'm just going to put a try catch around that thing, right? But what if the bug that happens because some state got corrupted, right? You can potentially continue running that software in a corrupted state, and then you can have error, cascading, and so on. In Elixir, what we're going to say, okay, I'm going to let this thing crash, and I'm going to start a new one to continue taking items from the queue. And this is a really important difference because I always like to do the example with computers, right? When our computers, they are not working, like something is weird. For some reason, my computer doesn't work. What do? We go restart it, right? And after we restart it, it's working again immediately. The bug is gone, right? And that's because when we do that, we go back to the initial state, right? And that's exactly what we are doing with our supervisors. We are not catching errors. We are not running on a potentially corrupted state. We are always starting from scratch. We are going to the position that is guaranteed to work. And those are really the two differences that matter here, right? We have those concurrent things that they have a very particular approach to error handling because they are isolated from each other, and which again goes back to concurrency, right? So it's kind of like those things all working together to change the way we write software.
Okay, great. So we've talked about the things that Erlang and Elixir share that make them so valuable to programming on concurrent systems. Now I'd like to break down some of Elixir's features. I'd like to get a finer grained understanding for how Elixir compares to Erlang. So Elixir compiles to bytecode for the Erlang virtual machine. What does that mean?
Okay, so what we do is, so basically what it means for someone that wants to write Elixir or Erlang software is that we compile to the same bytecode, and we do it in a way to share as much as possible with Erlang. So imagine when we are compiling code, right? There are a bunch of steps that to take some file that is in your machine, in your operating system. There are a bunch of steps to take that into something that can run, right, into the bytecode. And what Elixir does is that we share a lot of those. So that's the job of the compiler, right? To get the file in your machine, do a bunch of transformations, and make it something that it can run. And what Elixir does is that it shares a bunch of steps with the Erlang compiler. And that goes back to compatibility that we were talking about, right? So, and the reason why it matters is that for the developer, you can call Erlang from Elixir and vice versa without no performance cost at all. There is no bridging. The bytecode is going to be really close because they share a lot of those steps. So when we say that we compile to the same bytecode, is because everything that already exists in their environment, it's in the ecosystem, it's there for you.
Okay. And Elixir has there's a phrase associated with it. In Elixir, everything is an expression. What does that mean?
Great. That's also common to a good chunk of functional programming languages as well. In the sense, so if we're doing imperative programming language, we have something that sometimes we call like procedures, or we have things like statements. So, for example, in C, I think it has been such a long time ago that I programmed C, but if is a statement. So the if you have if in your code, that thing is not going to return anything, right? There is no value. If you try to get something out of the if, the compiler is going to complain to you, right? But in Elixir, for example, we don't have return because everything is an expression. You always can get a value out of it. So, for example, in an if, if you have an if true, you're going to do something else. You're going to do something else. The if is going to the if is an expression, which means it's going to return a value, which means that if the condition is true, it's going to return whatever is in the do block, right? Like if
so every line of code can return a value.
Yes, even assignment, right? So in a lot of languages, you can have like the variable a, and then you're assigning 1 to it, and that's a statement that doesn't return anything. But in Elixir, that's an expression, so it needs to return a value, and in this case, it's going to return a value which is the right side of the assignment. So a equals 1 is going to return 1, which means that you can do a equals b equals c equals 1, and it's going to cascade, right? We were saying that C is 1, and that's going to return and make B1, that's going to return and make A1 because everything's an expression.
Sure. And I think over time, if you're a developer that works in this type of paradigm, it improves productivity over time, in my experience. So Elixir also allows metaprogramming. What is metaprogramming?
Great. So actually, when we were talking about the goals, we talked about the tree, and I talked about compatibility, I talked about productivity, but I forgot about extensibility. And extensibility is exactly where metaprogramming comes in. So there is a talk I love from Guy Steele, which is called Growing a Language. And there in the talk, he says something like this. Now we need to go meta. We need to think of a language design as being patterns for language designs, tools for making more tools of the same kind. And the reason why it matters to me, it's because today computer science, it's a very wide field, right? There are way too many things. So there is no way we can design a language that is going to work well across all of those domains, right? Even inside one specific domain, like when I said everything that runs on top of a TCP or UDP connection, right? We can do so many interesting things and with a huge variety. So the language needs to be extensible. The language needs to be growable, right? And metaprogramming is one of the different features. It's one of the many features we have in the language to make that possible. So the idea behind metaprogramming is that we can have code that writes code. So to give it's kind of, I'm not going to try to explain it for audio, but to kind of give an idea of how powerful it is and what kind of flexibility it gives. Most of Elixir, it's implemented in Elixir itself. So you're talking about if, right? In a lot of languages, if and else, they are constructs of the language. They are constructs of the parser, right? You cannot change it, right? It's in the language specification. In Elixir, it's just a macro, because it's something that's going to look at the code and is going to transform it into something else. And I think this is really important, because what it means for developers is that the tools that we use to write the language, they are there for you to get it and extend it. And we have a lot of interesting use cases that where we use those features like metaprogramming to do a bunch of interesting stuff. So here's an example. Elixir has Unicode support, right? So for example, my name is José, and I have a cut accent in the last letter of my name, and there is specification how that should be encoded and so on, and that's what the Unicode says, and UTF-8 and so on. And the Unicode, it's a huge standard, and it has a bunch of files that tells you, for example, if you want to uppercase my name, you need to know exactly how to convert this letter A with an accent to the uppercase letter A with an accent. So it releases a bunch of huge files that say, these should become these and this should become this other thing. In Elixir, all those rules, right? We have a file which is probably today at 300, 400 lines of code. And what we do is that we parse those specifications from the standard and we generate code from them. And we compile it, and that's it, and it's done, right? With 400 lines of code, and because we are compiling it into code, we can optimize it because we can use the same tools that we use to optimize code, to optimize reading this database of how, characters, uppercase, lowercase should work. So this is one example where, we are getting some data, and then we're getting that data, transforming into code, and then we like to say that code is data itself. So we go transform the code, then we generate everything, and then we have it's actually quite readable solution because we're just parsing the files and emitting these code chunks, and it works well, and it's also really fast. So that's one nice use case. We have a bunch of other use cases that you can see when you're using our test framework. So testing is a domain-specific thing, right? You're testing, and also depending on the domain you're testing, you need more domain-specific knowledge. So that's a place where it helps as well. And there are a bunch of other examples that we could go on and on.
Well, so let's talk a little bit more about that, because metaprogramming can be used to build these, higher level domain specific languages, as you're talking about. And one feature you mentioned that you could build is a testing framework. What other kinds of things could people build using, with a DSL on top of Elixir?
So let's see a couple other examples. So if you want to go a little bit more about a web, there is this library called Ecto, which you can write queries that and you're using Elixir syntax to write those queries, and then because they are macros, when you're compiling your code, we can look at those queries. We are going to make them as close to SQL as possible, and then we can send them to the database. And this is really great because when you're using Ecto queries, we are going to protect you against SQL injection attacks. We are going to ensure that the types that you have in your database, they are matching with the types that you have specified in the Elixir side. So it brings a bunch of improvements. That's one example, really interesting as well. There is a web framework called Phoenix, and they have a router, and it's really, and the router is really interesting as well, because what you do is that you define all of the routes that you want to run in your application, and that your application serves, and then those routes is going to generate code very similar to when I was talking about Unicode. It's going to generate code that say, oh, if I have this route, I want to call this. If I want to have this other route, I want to call this. And that's also really well optimized, again, because you're going to get all those routes and compile. I like to say, as an example, that so depending on whatever you're using for web, there's a chance that if you have a bunch of routes, the algorithm they are using, it's kind of a linear router, which basically means that whenever there's a request, they go to a router and they check one by one, is this route that's going to handle my request? Is this other route that's going to handle my request? Is this other one? So they go checking one by one, which means that the routes at the end, it's always going to take some time, right, to get into them and finally match. And that's not, that's not efficient, right? You want to have better ways of doing that. And that's exactly what the Phoenix router does, except that they're just relying on how Elixir compiles code. They are not writing, they're not writing a binary tree search and so on. They just compile the code, they emit code in a particular format, and they get all the performance benefits. And when you look at the implementation, it's a straightforward implementation. You can look at it, you can reason about it, and you can move on. So those are a couple more interesting examples that we see.
So when you're talking about building domain-specific languages on top of Elixir that do things like testing and database connection, like with Ecto, or a web framework like Phoenix, are these things that would be much more difficult in raw Erlang?
Yes, definitely. So for example, I'm going to go for example. So the Unicode one would be just straight, really, really hard to do in Erlang. It's definitely doable because you can still get and generate the Erlang code, but it's not going to be as clean, it's not going to be as concise as the Elixir one. The router, for example, it's doable in Erlang if you define your functions in a particular way. So so there's not such a big mismatch in there. You can define routes also in Erlang very elegantly and get kind of similar behavior. So I don't think in that particular case it would be a concern. But something like the query syntax would be hard in Erlang. We need to depend on things like parse transforms, and parse transforms, they can actually be quite tricky to use. Because so I can go into that really, really soon. So it kind of depends. There are things that you could solve the problem in different ways and you get good solutions, but there are other ones that it would be really, really hard to do it. And I was talking about parse transforms and say we're going to talk about this later. Now is this later. So one of the concerns that people have when it comes to metaprogramming, which is a completely valid concern, is like, this sounds dangerous. This is risky, right? So in Elixir, we took a couple precautions to make sure that there is always some sanity in the insanity, right? So there's always a limit on what you can do with macros. So there are very important guidelines. So macros, they are always lexical. So for example, a lot of languages they have, so Erlang has parse transforms, some other languages have templates and so on, and they have ways, for example, where you can enable it for the whole project. You can say, all the code I'm going to compile, I want to pass through this thing that may change the code. In Elixir, for us, that's a no-go. We have no global configuration that's going to affect how things are compiled. If you want to use a macro, the first thing you need to do is that we are going to say at the top of our code, this code is using these potential things, right? It's using the Phoenix router stuff, or it's using the Elixir, the Ecto queries stuff, but it's always there. It's always going to be in the file. We say it's lexical, right? It needs to be there in the file, and it's going to be valid from the point you declare it below in that particular file. So that's one of the things that helps a lot. And all of the macro calls, they are explicit, right? You can't inject something that's going to change your code behind the scenes. You still need to call that thing in your code, and it will always be there in the code. So it's like a two-step thing. First you say, I'm going to use this in my code, and then every time you use it, it's also going to be clear that you're using it. And that helps contain and manage that, that potential source of confusion that macros can bring. And it always contains to one module. So in Elixir, it's really nice that so you get languages like Ruby and Python that they give you a lot of, you can do metaprogramming, you can do a bunch of interesting stuff, but they do that at runtime, right? Which means the code, the system can change under you while it's running in production. In Elixir, a lot of it is exactly contained into the modules, which are, they are programmed at compile time. So after you compile, you're going to have a module where you're executing the macros and so on, but that's it, right? You're not going to change it later on. When you're running production, there is no chance like a library or something is going to go to a particular place in that module and change things. So everything's much more contained, and that helps a lot, both with understanding of the system, both with running the system in production and understanding of the code.
I'd like to talk a little more about adoption of Elixir, and particularly through the lens of Phoenix. Ruby on Rails created such adoption of Ruby, and it coincided with a time when I think there were a lot of new programmers, and there were a lot of people who wanted to create applications that fit into the mold of a Ruby on Rails application. And it just created something that was really easy for people to onboard into this specific type of application that people wanted to build that was encouraged by Ruby on Rails. And Phoenix strikes me as a framework that has the potential to kind of do something similar, because we're moving towards a world where distributed systems are getting more and more important, and having a framework that thinks about distributed systems at the language level, it seems like it is ripe for just the right abstractions to be built on top of it that create the right framework for people to build applications that go into the future. Like I think about an application like Uber, for example. Uber has just got distributed systems written all over it. You don't want to be thinking about the edge cases and try catch blocks and stuff if you're building a distributed system for cars and riders in real time. And so I guess all that is to say, like, how are you seeing adoption of Phoenix, and how are you seeing, how do you project it going forward into the future? How do you see people using it, and do you think it has potential to catch on to the popularity of Ruby on Rails?
Great. So there is one very interesting thing about this, which is I've been working on Elixir officially since 2012, when my company Platform Attack decided to invest on it. And when Phoenix started to gain traction, it was really visible because it changed the kind of people and developers attract. So when they wanted to try Elixir, they wanted to learn the language, they wanted to try the language and get acquainted with it. But when you have like people interested in Phoenix, they want to get that thing, and they want to build a web application, right? So so there's this very interesting anecdote from the perspective of adoption, and at the beginning, there was really like it generated some kind of it's not I'm not sure which word it is. It's not uncomfortable, but it's more like puzzling and questioning, in the sense that we have a lot of people coming to the community, which is great, but they're not particularly interested in a lot of the things we talked about here. So and then people would say, oh, like they're not necessarily interested in the processes, or they're not first interested in the failure semantics. And a lot of people would say, we have all these people coming, but they are not worried about the foundation. And then I thought, you know what? It's actually fine, because if we want to have a diverse community, we are naturally going to have people specialized in different things. And so we're going to have people that their interest is in web, and web again on its own is such a wide field as well, right? They are like you need to know about HTML, CSS, JavaScript. You need to know about HTTP. There are a lot of things you want to have there, and it's understandable that some people, they want to focus on those layers and not on everything that can span. And I think this is great that Phoenix is it's attracting people with this interest, right? Because they'll come to the platform. And again, there are a couple of things that they can't escape, right? So even though they're not really interested about in the distributed part, in the process part, they can't escape about immutability. That's going to be in their code one way or the other, and that's something they'll have to learn. But I think this is a great sign because Phoenix is not only attracting the Uber people, the people that need to write distributed systems and they need to be connected with the driver's phone and so on. It's not only attracted that kind of interest, but it's also attracting people that they're just looking for a better platform for write their applications, a platform that's going to lead to more maintainable code, that's going to give you better performance guarantees. So that's one of the points of the adoption. But the flip side of that is exactly like there are people that are coming exactly because of those other things, right? Exactly because of what is said, because of the distributed system. And then they know, like, I'm running this application here, but soon I need to add real-time concerns, real-time constraints to this code, or I know that I will need performance, or even they are just looking again for that style of more maintainable code, or being able to write applications that rely less on cache because the runtime is going to guarantee you can go really, really far without adding layers and layers of cache. So so my perspective is that we are seeing both, and I think this is really, really great, and we should find a way of having both sides growing and moving on together, in particular to web, because when you ask, for example, about Rails, I think that's how we can get kind of the diversity and reach that Rails had. And it's not only about the web. So talking about Elixir in general, I've always designed, so I work at a company, Platform Attack. We are consultancy. We work with things that run on the web. So, and obviously, like my focus at the beginning with Elixir, when I did the proposal to them, I said, I want to invest on this language and on this ecosystem. I said, we are going to have Elixir 1.0, and at some point later, we are going to have really good tooling for the web, so we can build web applications, we can move our clients, we can get new clients, and so on. So obviously, there was that, but I never wanted to have to be a language for the web. And we already have kind of that just from the foundation of running the Erlang virtual machine. So as I said, all the binary protocols, TCP, UDP stuff, distribution layers, you can already build that, which kind of already gives a little bit more of diversity. But I want to take it even further. I want to bring more of, I think because of the way we can leverage concurrency, I think we can be a really great platform for things that need also to do a little bit more of data handling, get data from one place, processing it a little bit, put in some other place. We can make distributed programming even easier. There are a bunch of interesting ideas flying around. For example, we can get Orleans for Microsoft that it's worth checking out and see, what did they make it easy that people got excited about, and see how it can reflect on that. And more closely of them all, it's actually embedded. We have great folks like Justin, Garth, Frank working on improving how to write embedded software in Elixir, and it's really fantastic what they're doing. Like you can get your Elixir code and you can put it with the Erlang virtual machine and your operating system, like 20 megabytes, and then you're going to plug it in your Raspberry Pi or something like that, and it's going to boot in like 2 seconds. And they have already embedded software running on top of that with Elixir and so on. So that's an area that I'm really excited about. So in terms of community and adoption, I'm really looking forward. And I hope that others will also get interested and continue to push those areas so we can get a more range and more diversity.
That's great. Well, it sounds like an extremely unique community. It is like the merger of distributed systems researchers who are just curious about distributed systems, and then these people who are interested in like at the application level practicality, just like building something, like the Ruby on Rails type of people. So, okay, well, that's a great place to close off. Jose, thanks for coming on the show and talking about Elixir. I think this is a fantastic project, and I will be tracking it closely. Thanks for coming on Software Engineering Daily.
Thank you so much. I had a lot of fun.